Welcome to the future of manufacturing. For over 100 years, building a car was an act of chaos. It meant thousands of robots, millions of sparks, and welding 70 different pieces of cheap steel together. It was slow, it was expensive, and it was weak. But Tesla doesn't do that anymore. Inside this factory, the rules of physics have changed. Meet the Giga press. It is the largest die casting machine in human history. It weighs more than a Boeing 747 and exerts 9,000 tons of clamping force. That is the weight of the Eiffel Tower, crushing down on a single mold. Other car companies said this machine was impossible, but today we are going to show you how it prints a car in 90 seconds. The process begins with pure alchemy. Solid aluminum ingots are fed into a melting furnace heated to 850 degrees Celsius. At this temperature, the metal loses its form. It flows like heavy syrup. It is no longer steel and bolts. It is liquid potential. A robotic ladle scoops the molten aluminum with surgical precision and transfers the liquid fire into the shot sleeve of the press. Speed is critical here. The machine engages a massive vacuum system, sucking out every molecule of air. Then, the strike. A piston fires the metal into the mold at 10 meters per second. The Giga press clamps down with 9,000 tons of force, holding the liquid metal in a vice grip as it turns to solid. It holds this immense pressure for just seconds. Then, the mold opens. A cloud of steam releases and the Godzilla robot reaches in. What was once liquid fire is now a single, solid, perfect car chassis. No welds, no glue, just physics. The part is dumped into a quench tank to freeze the metal structure instantly. Then it moves to the trim press. Watch this. In one violent motion, the trim press snaps off the excess metal edges. It cleans the part instantly, recycling the scraps back to the furnace. Nothing is wasted. Speed is nothing without precision. The casting enters the X-ray chamber. Blue lasers scan every millimeter of the surface, while X-rays look inside the solid metal, searching for air bubbles. There is a flaw the size of a grain of sand. The part is rejected. But this one, it's perfect. The grain structure of this aluminum is tighter than steel. It is lighter, stronger, and cheaper.
Showing the tightly packed crystals. This explains why it is strong.
As you can see in this comparison, the old welded frame is weak and rusty. The new cast frame, however, is solid and shiny.
When Tesla installed the first Giga press, the industry laughed. Now, they are panicking. Toyota, Volvo, and Chinese giants are scrambling to order their own massive presses. They realize the math is undeniable. By replacing 300 robots with one giant press, you save 40% on factory floor space. And it's only getting bigger. New machines are being built with 12,000 tons of force to cast the Cybertruck. We are moving toward a future where an entire car can be printed in just 3 pieces.
If these Giga presses are fully operational by Q3, we have a serious problem.
Analyze the structural impact. We need a response immediately.
What started as a pot of molten aluminum has transformed the global economy. The assembly line has been reinvented. From liquid fire to solid motion, this is the Apex process.